Okay, previously this question seemed to have some problems, so I am now doing it again. Okay, so for this question, we will take a substitution. U is equal to 3x plus 2y plus 2. We can even take without 2 as well. So the answer will be same. Okay, so we can take it with 2, without 2. Yeah, there will be no change in the answer. So let's try. Let's take it without 2. So 3x plus 2y is equal to u. Okay, so we will take this substitution. Actually, for the substitution, I prefer to use this symbol. Okay, so this will give y is equal to u minus 3x divided by 2. Yeah, from simple algebra, y is equal to u minus 3x divided by 2. Okay, and if I take the derivative, du divided by dx, du over dx will be given by 3 plus 2 dy over dx, or in other words, dy over dx will be given by du over dx minus 3, and then whole term divided by 2. du over dx minus 3 divided by 2. Okay, so these are the substitution which will be used. So I take this original differential equation and now substitute two of the values. One is y and the other is dy over dx. I close the bracket, so I shift enter, and then I get this. So now I can take this output, and then now I can separate the variables. So for separating the variables, what I can do is I can simplify this right hand side. So in this case, simplify. So it will be like this. It doesn't make it did not do anything over here actually, anything. So what I can do is I can just try to remove these quotients. So then for this I will multiply by 2 multiplied by dx, and yep, maybe this should be enough. effort now, and then I multiply the same on the right hand side. And then what I can do is I can these two brackets are for simplify. Okay, so for this bracket for simplify I take here, so that I can get a relatively simplified expression. So now I get like this. Okay, so but I still have this dx term on this side, so I take this 3dx term on the other side. So I add 3dx on both sides. So plus 3dx and plus 3dx. So now I get this. Okay, and somehow I don't have this u du here. Where did this go? Oh, maybe I forgot to copy it. Well, it should be du minus 3x. Du. Okay. Yeah, so it is now du is equal to 3dx. Okay, so now all the dx terms are here, but here I have u terms, so I need to take those u terms from here to there to the other side. Like I need to simplify this right hand side as well, so maybe I can input the simplify command here, simplify, and then this one. Yeah. Okay, now I get like this. Yeah, so after simplification it has taken out this dx as common factor, and then I get this. So now I can take whole of this term to other side, and then our separation of variable process will be completed. So for this, then I need to multiply by 2 plus u, and then divide by 6 plus 5u, 6 plus 5u, and then I can multiply on the left hand side as well. So something has happened. Yeah. So Control C, Control V. Okay, so multiply both sides by 2u over 6 plus 5u, and then okay, so now everything has been arranged. So now what I can do is I can take the integration of both sides by removing du and dx. So in place of dx we will put 1 comma x, and then integrate and integrate this one. This integrate will be with respect to u. Yes, now it's complete, so shift enter, so I will get this value. So at the next step I will add a constant of integration, c here. Okay, and then I will replace the value of u in terms of x and y. So u was here 3x plus 2y. Yep. So I will shift enter. So I will get this. So this is the solution. And in this case, the term over here 6 divided by 25 is a constant. So this constant can be combined with this constant. Okay. So what we can do is I can manually remove this term from here. That means I can manually remove 6 from here. So now there will be no other constant term. So that will be considered included in this value of c. And then I can take also x to that side, so that all the constant on the other side there is just a constant. Okay, so it will be like that. So this will be the final answer. So now we need to find the value of this constant. So the value of this constant is given by this expression, and then from the initial value conditions. From the initial value conditions. Okay, so we need to input over here initial values. So what are the initial values? Y minus 1, x minus 1. These were the initial conditions. So y minus 1 and x minus 1. These are the initial conditions. And one more thing we need to do is we need to take the absolute value of the log. Actually, for whenever we take the integration and our answer is in terms of the log, we take the absolute value. But for normal situation, we don't care to represent that absolute value. So therefore, we should take the absolute value of the argument of this log over here, absolute, and then close this absolute over here. Okay, so now we can input these values. So it will be this, and then we get this. I think this needs to be simplified. So as a last step, we can simplify it. Simplify. In simplification, then this 1 and then minus 1 will cancel out. So we get this 4 log 19 over 25. This is the value of the constant. So the final solution will be this with the so replace c with this value. This is okay. So this is the solution finally for this question.